Okay, this is the third in a series of videos about special points of concurrency in triangles. And so we've already done the circumcenter and the incenter, and now we're going to do something called the centroid. Now, in order to find the centroid is the point of intersection of three medians. Well, what's a median? Glad you asked. Here's the answer. A median is when you take the midpoint of the side of a triangle and connect it to the opposite vertex. And when I say opposite vertex, it basically means the vertex that wasn't involved in that side. So here's a side of a triangle. And so there's two vertices that are involved in this side. So the opposite vertex is the one that's not part of that side. So we're going to do three medians. And medians, again, divided into an equal parts. But it's not like the perpendicular bisector, because remember, with the perpendicular bisector, we had to have a special angle. Here, we don't care about the angle. All we care about is that both sides are congruent. So here's the midpoint. When you find the median of each side of the triangle, here's a green one, here's a pink one, here's a blue one, boom. They intersect at this point called the centroid. What's so special about a centroid, you ask? Well, here's what's special about a centroid. That's the point inside the triangle where it actually divides the medians into perfectly 1/3, 2/3 parts. Or you can say that the longer part is double the shorter part of each of the medians, or the shorter part is half of the longer part. Okay, and so you can use that for all your calculations and all that kind of stuff. But right now we're just going to construct it with patty paper. All right, so here we have this acute scalene triangle, and we want to make three medians. All right, so remember what we said was that we wanted to find the midpoint of this side. Well, if I had a string and I wanted to find the midpoint of it, and I didn't want to use a ruler, maybe I don't have one, then I can just take the two ends of the string, put the ends together, and fold it, and boom, I found the midpoint. Same thing here. You just take the side, it's just not a string, it's just on a piece of paper, and you fold C and A such that they touch each other. All right? Now, I don't want to make a whole fold in this triangle because that's going to give me a perpendicular angle, and that might not be what I want. I'm just going to do what's called pinching it. So I'm simply putting one end on top of the other end, and you can clearly see that from C to my fold and A to my fold are the same length because I made it that way. So here's my little pinch. What's the point of the pinch? I found my midpoint without any measurements whatsoever. So there's the midpoint. Now to make the median, I need a ruler, and I'm going to simply connect my midpoint to the opposite vertex, okay? I'm going to use a solid line this time. I'm going to use my tick marks, and these tick marks are here to indicate that this side and this side are congruent. That's how I made it. So let's do side BA. All right, so we want to find the midpoint of BA, so we simply fold B and A so that the ends overlap each other as close as possible. And then I'm not going to fold the whole piece of paper. You can, it's not a big deal, but I just wanted to find the midpoint. So here's the midpoint. I'm going to use my tick marks to indicate such. And then I'm going to connect the vertex on the opposite side to my midpoint. There it is. And then I have one more side to work on. So again, I'm going to fold B and C on top of each other such that I know that the distance from B to my fold and C to my fold are the same distance, okay? I'm just going to pinch it. I call it pinching. It's not really pinching like you do on St. Patrick's Day or something, but whatever, it is there. All right, so then I'll put my tick marks on there, and then I'm going to, and hope that my last median, oh my goodness, intersects at the same point. So what did I find? I found the centroid. The centroid is actually that point of intersection, which is why these are called points of concurrency, that point of intersection of the three centroids. Well, let's check our theory, because in the beginning we said that if we had the centroid, then one of the medians, each of the medians actually, are going to be divided into a 2/3, 1/3, 1/3 portion. So let's try one. I like to use my millimeter side because I can make a little bit more accurate measurements. All right, so this is about 61 maybe millimeters. Okay, so we know that 1/3 of 60 is 20. So the smaller side should be right around 20 20 millimeters, and it is. And the longer side should be around 40, and it is. Oh, I measured that wrong. Sorry, it's about 66. So let's look at this one. The green one is 80. I'll try to measure correctly this time, just to give you a little laugh. Okay, around 82. So if I were to divide 80 into 3 different parts, 20, help me out. I'm a math teacher. I'm having a hard time, sorry. All right, so 82, let's just do it on here. Okay, so 82 divided by 3.
87.
Is about 27.
Yeah.
Yeah, Miss John got it. She got it faster. She's better. Okay, so about 27. So one side should be about 27. Look, it is. And the other side is double of 27, which would be, what, 54? Yeah, there you go, 54. So basically, that's the whole point of a centroid. Well, you might ask, what happens if you have a right triangle? How would that work? Well, it would work the same way. So let's look and see how to do that. So we fold A to C so that they perfectly overlap because we're trying to find the midpoint. We only care about the midpoint, and then we're going to draw a line connecting the midpoint. Here, let me just mark it with tick marks. The midpoint with the opposite vertex. That's the median. Now we want to find the midpoint of this side without measuring or math. This is easier. You just fold one end over top of the other. Make a little pinch or a little fold. Now you've found the midpoint of this side. And we'll mark it with our tick marks. And then we're going to connect the midpoint to the opposite vertex. And then the last time, now we have side BC. So we fold B on top of C, such that B and C touch each other exactly. And we just make our little fold there. And again, the fold was just to indicate our midpoint, sorry. And here we go. And then we're going to connect the midpoint to the opposite side. I can see the fold better. I don't know if you can see it on the video. I made kind of a mess because my pencil wasn't sharpened. All right, and then we go here. All right, and look, the centroid is here. And if you were to measure the green, the blue, and the orange, they would be divided into 1/3 for the small. Each part has a 1/3, and then 2/3 for the longer side. All right, what if we had an obtuse triangle, you ask? Well, I was ready for that question. So here we go. C over top of A. Yeah. Don't try to trick me today. Okay, unless I'm trying to divide 82 by 3. Okay, there's the midpoint. All right, so we'll mark it. I guess I decided to start with 2. That's cool. And we go from the midpoint to the opposite side. And then we're going to do AB. Now, just because it's obtuse, just still treat it the same way. A over top of B. We only care about the side. And then we pinch it right there. We found our midpoint again. All right, we'll use 1 tick mark this time. Now, it looks kind of weird in an obtuse triangle. You're like, okay, so what's the opposite side again? Or what's the opposite vertex? Well, again, since this side included A and B, the only vertex it didn't include was C, so that is called the opposite vertex, because I know it looks kind of weird, and so it's trying to figure that out. Okay, now our third side that we need to do is BC. So we fold B on top of C, such that they match as best as you can. And then now I found my midpoint, so I'm going to mark it with orange. And then the tick marks indicate that they're the same distance. And again, we used vertices B and C on this side. So A is the one that's not involved. So that's called the opposite vertex. So we're going to go from here to here. All right, and they intersect at the centroid. Awesome. So now you know how to do it. You take 3 medians of any kind of triangle. It can be a right triangle, acute triangle, obtuse triangle, equilateral, it doesn't matter. And you take the 3 medians by finding the midpoint and connecting it to the opposite vertex. And where the 3 medians intersect, the point of intersection is called the centroid, and it's 2/3 of the distance is the longer side and 1/3 is the shorter side. Stay tuned for the orthocenter.